All right, hello everyone. Um, Still not feeling too good, still not sounding too good, I know, but thankfully we got everything recorded ahead of time. So what I'm going to do is real quickly show you where you find your midterm review, just in case you need to see it, and then we're going to do some more total change problems. We'll do that for about an hour, and we'll be good for the day. Looking for this. I just want to make sure that my MDE 54 class saw that where the midterm review was. Again, it's in your Math 154 course inside of Canvas. And then if you scroll down, probably about halfway, maybe a little past halfway, depending on how you have your tabs set up, if you collapse anything, if you'll have that option. I know I do, maybe my students don't, can't remember. Doesn't matter though. And sorry if you hear my dog whining at me. Anyways, this is your review. And you can see that it's pretty expansive. Like we said in class, it's about 55 questions roughly. You'll notice that in the title of it, it does say to skip one of them. I think it was 47. Yeah, part 2 of 47. You're going to skip this one. So 55 questions, and I had a student ask me, well, how do we know if we get the answer right? Well, if you paid attention when I was talking about this in class, you would have heard me say, at least once, maybe twice, that the answer key is also provided in here. So that's how you know if you got it right. Now, if you don't get it right, how do you figure out how to do it correctly? Well, you go back to your notes and review stuff. You go back to the videos and review stuff. You find similar homework problems and you review them. You'll find little ID tags, and the first two numbers tell you the chapter and the section. So if you're having a problem with number 57, then you can go back to section 2.4, and there's probably a homework problem that's similar to it. Notice I said probably, it's not a guarantee, but you should still, if this is an instance of there is not an exact duplicate or something close in terms of a homework problem, it should still be the same concept as something from that section. So the notes, the lecture, everything else should be able to help you get to where you need to be. The midterm itself will not have any kind of tags like that. No, absolutely not. That's a good question. If anyone was thinking that out loud. And yeah, so today what we're going to do, since in the regular lecture we just talked about total change and percent change, we're going to do some of those calculations. And let's not waste any more time. Let's go ahead and get into it.
Find the absolute change and the percentage change in the following case. The average sale of a house decreased from $303,000 in February of 2008 to $182,000 in February 2013. So this problem relates to the housing crisis of 2008, where these values had ballooned up just a ton. They were overvalued, and this was due to various reasons that we don't need to get into for the problem. All we got to do is just talk about the total change, which is another word for absolute change, as well as percent change. So we know the original, or old, however you like to phrase it, was the 303,000. And then the new is the 182,000. Now remember that the absolute change or total change is always new minus old. It's not bigger minus smaller, it's new minus old. So it's 182,000 minus 303,000. And if you really need to pull out a calculator for that, you can. You don't really need the zeros. I can tell you they're just going to subtract perfectly. Ignore that trigonometry. So we're doing 182 minus 303. I can just tack on the zeros afterwards. And it's negative 121. So negative $121,000. In other words, that was a decrease in value of $121,000. Now remember, when you use the word decrease, you do not put a negative there. The decrease implies that that action is negative. So it just depends on how they're phrasing things. So since they say the absolute change is, they do want the negative. They're not asking us to write out the decrease is this or the increase is that. So we got 121,000. Now I actually hope that it tells me negative 121,000. I thought I typed my negative. I hope it tells me that I'm wrong, because this really should be a dollar symbol. And I knew it wouldn't, but really I should have typed $121,000. That would be a better quantitative answer, right? Because then we have our units. The relative change, now relative means percent change. And the formula for percent change, as a reminder, is the total change divided by the original. I'll actually write that one. Percent change is the total change divided by the old or the original. And then you have to convert to a percent. So for this problem, we take the total change, which was the negative $121,000, and we divide it by the original, which was the $303,000. If we divided by the 182,000, I can tell you we'd get a bigger answer because we'd be dividing by a smaller number. Remember, dividing by a bigger number makes the answer smaller. Dividing by a smaller number makes the answer bigger. And then you can just do this in your head. I'm kidding. The units will cancel. You will be stuck with a negative. And calculator. So now we're going to do 121,000. And again, I don't actually need these zeros, but divided by 303,000. If you're not sure when you do or don't need them, put them. And if you don't believe me, here's 121 divided by 303. I still need the zero between the threes, of course. Same answer. But then we got to convert that to a percent. And a nice way to do this in a calculator is you can just multiply by 100 instead of moving the decimal right twice. And you get 39.93 blah, 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 blah. They asked us to round to the nearest tenth, so that would be 39.9%. And it's a negative, of course, so that means there was a 39.9% decrease in the value of homes on average. Let's see if that's right. 39.9, and they have the percent symbol in there for us already. And did I forget my negative? I did forget my negative. That's all right. Negative 39.9, that's twice. There we go. I want to go back to this one, and I want to make sure that it would have accepted this answer in dollars. So 338,163. So we're going to do 163 minus 338. So negative $175,000. So that's annoying. That's pretty ridiculous, in fact, that they would not take it with the units in there. I'm not a fan of that. That goes completely against the quantitative reasoning logic and way of thinking, but it is what it is. Okay, I'm not going to focus on that. I'm not going to hyperfocus. Yes, I want to leave the question. Save best score. I don't want to get any bad scores. Find the absolute change in percentage change. So the number of daily newspapers in a country was 2182 in 1900 and 1208 in 2010. So I'm going to do this wrong for a second. I'm going to do this wrong for a second. And I'm going to go, oh, okay, well, the old was 1900 and the new is 2010. So I do 2010 minus 1900, right? Well, no, because those are the years. Years are labels. Years are generally labels unless you're trying to do like a slope or something like that, which we'll get into later. But no, those are not the numbers we are dealing with. We are dealing with the number of newspapers, which was 2182. That's the old. And the new was 1208. And that was papers. So the total change, or the absolute change, interchangeable words there, is new minus old, which is 1208 minus 2182. And if you're wondering, and this should be labeled papers, papers, so then the unit of the answer is papers. And yeah, these absolute changes, they're just not putting units anywhere. Not a big fan of that once again, but I won't say anything past it now. So you do your 1208, you subtract your 2182, you get negative 974. So almost 1,000 papers in a decrease. Why is that? Because of the internet, right? So make sure you get your sign in there, negative, and then 974. That should be our answer. There we go. There's our absolute change. And that would be 974 papers that's decreased, But again, my math lab is ignoring that aspect. The relative change or the percent change is the total change divided by the original. So the negative 974 papers divided by the original, which was 2182 papers. So negative 974 divided by 2182. And I have something up there that's going to make a mistake. So let me that. Negative 974 divided by 2182. I know why, because that does not actually work. I'm trying to use my mouse and my keyboard, and the negative doesn't actually work. So I got to type this, negative 974 divided by 2182. See how that negative looks just a little smaller than this one? That's because this counts as a subtraction sign. And yes, mathematically, subtraction is a negative, but calculators are weird. So there's the answer as a decimal, negative 0.44, blah, blah, blah. If you round this to negative 0.4, this is going to be wrong because this is a decimal, not a percent. Move the decimal right twice or multiply by 100, however you like. And there's the answer as a percent. We're going to cut it off at the tenths, so negative 44.6. Negative 44.6%. Drum roll. What did we do wrong? Did I type a number wrong? Negative 974 divided by 2182. Da, 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 da. I see what I did wrong. I didn't read the instructions, did I? I got used to what everything else was telling us to round to the nearest tenth, round to the nearest tenth, and they tell us to round to the nearest integer. So this should not be negative 44.6. This should be negative 45. Drum roll. There we go. See, the devil is in the details. Now, again, on a test, that's the type of thing that I can go and give you partial credit for if you point it out to me. And maybe not even partial credit, maybe full credit if your work is good and it was just a misrounding. I mean, maybe 4 to 5 points. That's usually what I would do. If you have a rounding error, if you didn't pay attention to the details, 4 to 5 points is usually what I give. All right. The gestation period of cattle is some percent longer than the gestation period of pigs. So this one, there is no old and new specifically. It doesn't say this thing happened first, this thing happened second, because we're not comparing the same thing to the same thing. We're comparing apples to oranges. We're comparing cattle to pigs. So which one are you supposed to call the old and which one are you supposed to call the new? Well, we had said that you need to use the language to determine which one is the quote old. So when they say longer than the gestation period of pigs, we're going to say that pigs is the old since that is the one being compared to. If they had said pigs blah 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 percent longer than cattle, then we'd call the cattle the original because it's the longer than that is what signifies what we're going to call the original. Again, it's not really an old and a new in that sense. It's just us deciding to compare one thing versus another and which one we're using as the baseline. And this language says to use the pigs as a baseline. And I'll show the math both ways just to show you the comparison. And this is very similar to the guided activity we did in Thursday's class a week ago when we were comparing, oh Lord, what were we comparing? Non-families to family households. That's what it was. So there's no really old or new. It's just a matter of choosing which one's our baseline. So our old is the pig's number, which is 115 days. And the new is going to be the cattle, which is 283 days. So then our total change would be just the difference of new and old. So 283 days minus 115 days. And again, if you need a calculator, you can always pull it out, whether it's easy problem or hard problem, 283 minus 115. But that is something you should be able to do on your own just by borrowing, and you get 168. So 168 days. That was weird. Okay, so there's our total change. So our percent change should be the ratio of the total change to the original, so 168 days in comparison to the 115 days. So we do 168 divided by 115, and we get 1.46. Now some people will think this is a percent because they got a whole number at least in there, and that's wrong. This is still just a decimal. So you got to take that decimal, multiply it by 100 or move it right twice, whatever, and you get 146 and some change percent. They say to round the answer to one decimal place as needed. We're going to pay attention to the instructions. So that would be 146.1%. And that's a positive number, so that's an increase. Both of those were an increase. So the cattle, in comparison to the pigs, have an increase of 168 days in gestation period. As a relative change, as a percent change, that means it's 146.1% more than the pigs. It's not saying it's 146% of that value, it's more. That's the increase in it. So let's see if we get that right. 146.1, they already have the word percent in there, and we got it right. Excellent. And before we move on, I said I was going to do this backwards. So what if we said the gestation period of pigs, I meant to switch color, is blah, blah, blah percent longer. And I'm going to say longer here in quotes just because I'm not going to change that word, but it is wrong than cattle. Why is it wrong? Because the pigs are shorter than the cattle, so how could this be longer? So it should be shorter, really. All right, so now we're going to call the old the cattle, which is 283. The new will be the pigs of 115, and all our days. So our total change is the 115 days minus the 283 days. I'm just abbreviating days there, which would be negative 168 days, and that would be a decrease. So it's 168 less days. Pig's gestation period is 168 days less than the cattle. As a percent change, that would be the total change of negative 168 days divided by the original, which we are now calling the 283. And when we do that division, negative, I gotta hit the negative there, 168 divided by 283. We get negative 0.59, blah, blah, blah. We multiply that by 100 to convert it to a percent. And round it to the nearest tenth, that would be negative 59.4%. So that's a 59.4% decrease in the length of gestation period when you consider the cattle the baseline. So because pigs have a shorter period of gestation, then that percentage is less than 100, because the other way around, cattle's longer, it's more than 100. It just depends on what you're calling the baseline. So yes, there are plenty of things in the real world that it makes sense to call one thing the old and one thing the new because it's based on time. But we also like to compare two things that have nothing to do with time. We could use this to compare percentages of votes of Democrats versus Republicans and how they've changed over time. Or not even in time, just comparing the Democrats to Republicans. So one of them would make sense to call an old and a new. One of them, if you're just flat out comparing Democrats to Republicans, What are you calling the baseline? What are you calling the quote old? Well, I don't know. How do you want to scare the news? How do you want to portray the information? Or maybe there is just one and only one way to consider it, which in that instance there is not, but you get the idea. All right. Another case of there's no real old and new, it's just a matter of deciding which one's the baseline. Now, if you're talking about country A and country B, I think, for me at least, if I live in country A, I would call B the baseline so that I can think of myself relative to them. But maybe you want to think the opposite way, so maybe you do it the opposite way. Again, opinion. So the number of deaths due to poisoning in country A in a year, 25, 100, is blank percent greater than the number of deaths due to falls. No, they're not comparing country A to country B. They are comparing deaths due to poisoning versus falls. But the same idea, this is a category A and a category B. So which one are we going to call old and new? Let's see. The number of deaths due to poisoning is blah, blah, blah percent greater than the number of deaths. So that tells us that the number of deaths due to falls is our baseline. That's our old. And then poisoning would be the new. So our total change would be the new minus old. I'm not going to write the numbers down this time. So the new we said was the poisoning. That's 25,100 minus the new, I'm sorry, minus the old, which was the 21,300. What's that going to be? 3,800. You don't trust me. 25,100 minus 21,300, 3,800. So that's 3,800. And of course, units, these would be deaths, and that's positive. So it's an increase. So there were more deaths from poisoning than falls. And if you look at all this stuff, that makes sense because they talk about this being a percent greater than, and the falls is lower than the poisoning. So everything does flow together very well. Then the percent change would be the total change of 3,800 deaths divided by what we were calling the original, which was falls. That was the 21,300. We can just do divided by 21,300, boom, times 100 to get to a percent, or just move the decimal right twice. Remember, don't round too soon. If you round the number before you convert it, you may end up of rounding too soon, and that's kind of what the hints are about round all intermediate values to two places, whatever before. So 17.8 if they want one decimal, which they do, 17.8%. Drum roll, and we got it right. Give me 30 seconds. All right, didn't even need that much. All right, another problem that I alluded to in the notes of the regular class. State whether the following is true or false and explain why. If the statement is false, state the true change. If the profits in your consulting business increase by 4% one year and decrease by 2% the following year, your profits are up 2% over 2 years. So this relates to that problem where I said, okay, one day you make 50% profit and the next day you lose 50% profit. Are you happy, sad, or indifferent? And it turned out we were sad because the 50% gain doesn't make up for the next day of losing 50%. And even in vice versa, you end up with the same scenario. So a 50% loss has a greater effect than a 50% gain. Even though, 50% of 100,000 is 50,000, but when you take the 50% of the gain or the loss, then it goes a different way. It's either 25,000, 75,000, depending on the order of everything. So this is where we said you can use that formula that the new is equal to the old times the growth factor, where your growth factor is 1 plus x as a decimal. So the x right here, that's your growth rate as a decimal. Now this also works for decay, so this would have also worked as decay factor, except a decay factor is 1 minus that decay rate. So this increase, 4%, that's a growth. A decrease, that's a decay. Growth is up, decay is down. So here's what we're doing. We've got 2 years worth of information here, so we can't just crank out the answer instantly. We have to process the first year to get to the second year. So the first year we gained 4% profits. Now, how much money did we have? It never actually says anywhere. So to use this as a baseline, let's just assume we have $1. Profits originally. Just so that we're only focusing on the actual growth or decay factor, because if the old is 1, then it doesn't even really need to be seen there because 1 times anything is the anything. So your profits in the consulting business increase 4% 1 year. So if we say year 0, we have the $1 in profit. Then year 1 would be the old, which was the $1, times the growth factor. Now a growth factor is 1 plus the x, but not as a percent, as a decimal. That's this 4%, but we need to convert 4% to a decimal, which is 0.04. What's going on here? Why is it 1 plus 0.04? The 1 here represents the original 100% you had. This 0.04 represents the new 4% that you're getting. And again, this is going to be a very common theme. So this is 1 plus 0.04 is 1.04. And 1 times 104 is 104. So that's our profit for year 1. And again, I'm saying year 0 was the dollar profit. The 1 year here is what I'm calling year 1. And then year 2, again, it's the old times the growth or decay factor. This time we're decreasing by 2%, so we're going to decay. So we have to go 1 minus that 0.02. So we take the old amount, which is not this, it is not this anymore. The old amount when we're talking about this year, oops, is what we just got. This is what we call an iterative process, not irritating, iterative, which means to do year 7, you need year 6. To do year 6, you need year 5. To do year 50, you need year 49. So if I wanted to do this all the way 5 years out and I had 5 years worth of numbers, I would have to do it step by step by step with all these different rates. Now, if they're all the same rate, we can do this in a non-iterative process, which means we could go straight to year 5 or 40 or 50. We'll get there later. All right, so we take the old, which is this value. This is the old in year 2. It's the amount from year 1. So we take that 1.04 and then we multiply it by its growth or decay factor. Since it's decay, we go 1 minus, and we lost 2%, which is 0.02. Remember, the decimal goes left twice, or you can divide by 100, whichever way you like. So this is $1.04 times 0.98. We're definitely going to want a calculator for that. Save some time. 1.04 times 0.98. So that's saying that we'll have 98% of the $1.04 left, which is, when we round to the nearest penny, because money, 1.02. So if the profits in your consulting business increased by 4% 1 year and decreased by 2% the following year, your profits are up by 2% over 2 years. Now you might say true because this is a 0.02, but here's the facts. We rounded that. It was 1.0192. This is not technically 1.02. We had to round. This is less than that. So it is not true that we just have 2% gain. We have a little bit less than 2%. And because our base was a 1, all you got to do is subtract the 1 and convert it to a percent. So multiply by 100. And that's the true growth that we've seen. It's really 1.92%, even though the bank's going to round up and give us that extra, tenth of a penny or whatever. Excuse me. Yeah, no, I was right, tenth of a penny. So false. If your profits in your consulting business increase by 4% and then decrease by 2%, your profits are actually up by 1.92% over 2 years. See, it's very close to 2 because these numbers were small, 4% and then 2%. So it's pretty close to what you think it is, but as those numbers get further and further apart, and as you invoke more years into this, it doesn't really work as what's the word I want to say? It's not as close. It's not nearly as close. And if we had more than $1 in here, we wouldn't have rounded that to 2 pennies. If we had, say, $1 million in this, you definitely would have felt that 1.92 instead of a 2%. So when we talk about percent change over several years, things are a little crazier. Again, that 50% increase, 50% decrease. It feels like you'd be back at the same amount, but in fact, we had lost $25,000. And that's what this problem is trying to invoke your brain cells to understand. I just think my problem being a little more extreme in the numbers makes it more obvious. All right. By turning off her lights and closing her windows at night, Maria saved 130% on her monthly energy bill. It's just true or false, does it make sense, and why? The claim could not be true, the claim could not be true, the claim could be true, the claim could be true. Okay, so we got 2 for not true, 2 for true. And then on top of that, they say it would not be true because her new monthly energy bill would be minus 70% of the previous monthly energy bill. This is impossible since the bill cannot be negative. The claim could not be true because her new monthly energy bill would be minus 30% of the previous monthly bill. This is impossible because the bill cannot be negative. So these two things are making the same argument that your bill is going to be negative, which is impossible. They just have 2 different numbers here, a minus 70 and a minus 30. So the thing about a percent change is you paid 100% last month. We're saying that she's saving 130% on her energy bill. How could you save 130% on 100% of something? That's an extra 30%. So it seems like B is the answer because that's 30% more than what the original bill was. The claim could be true because her new monthly bill would be 70% of the previous monthly energy bill. Again, no, that's not how these are working. The claim, blah, 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 30%. No, it's got to be B. It's got to be B. And it is. So when we're talking about a change of things, percents are a little wackier. It's not just one thing divided by the other thing. That's not what was going on here. It was an old times a percent value to get to a new. Determine which of the following claim could be true. Restaurant prices have increased 112% in the last 20 years. So we got 2 for true and 2 for not true, and let's see why. The claim could be true because an increase of 112% would be 12% of the original prices, which is possible. The claim could be true because an increase of 112% would be more than double the original prices, which is possible. The claim could not be true because the resulting prices would be negative. Well, increase negative, that's obviously wrong. The claim could not be true because amounts cannot be increased by more than 100%. That's completely wrong. We can increase amounts more than 100%. If you sold 3 apples, or what was it I said? I think it was 2 apples. If you sold 2 apples Monday and then 8 apples Tuesday, that turned out to be a 300% increase. We can have percent changes bigger than 100%. So C and D are out. It's either A or B. So the question is, If there's an increase of 112%, is that just an extra 12% of the original price? Like, for instance, if something cost $100 before, is it now costing you $112? Or is it true because the increase would more than double the original prices? Remember, an increase is not saying, oh, we're just paying that extra 12%. It's saying we're paying this much extra. The original 100% was what we previously paid. We're now bumping that up another 112%, which really means the effective answer is going to be 212% of the first answer. So it is more than doubling. And in the last 20 years, it is very easy for restaurant prices to double. Commodities like that tend to increase more than inflation, whereas other things like technology tend to not inflate at the same rate. In fact, often they deflate. And we got it. All right. Let's do a few of these. Go into the other side of things. And some of these I might intentionally answer wrong and just kind of make us think a little deeper. You know how I do with that stuff. Which would be the best strategy to use to quickly answer this following math problem? Two roommates evenly split the monthly electric bill. This month, each roommate has to put in $25 plus some change. That's very specific, right? How much was the total electric bill out of A, B, or C? So what would be the best strategy to use to quickly answer this? Eliminate incorrect answers, test each answer, or none of the above. Well, it's not none of the above. Eliminate incorrect answers. I mean, that's a good idea for a multiple choice question. And it might be right, and it is. Eliminating incorrect answers. Now, which of these could have been incorrect? If you're paying $25 each, there's two of you, that means you're paying at least $50, double it. But you're also putting in some change, maybe 10 cents, maybe 15 cents, maybe 60 cents. They didn't say, but because of that extra change, it's not possible for the answer to have been A. It could only be B or C. If it's B, that means you paid $25.25 each. If it's C, that means you paid $25.16 and $25.17. Someone's going to have to chip in the extra penny. It just means that, again, the bill is $50.33, so someone paid an extra penny. We cannot actually determine whether B or C is the answer here. That's why test each answer wasn't going to work, because you can't test these specifically. They did not give us enough information. What words in the following problem give you clues that help you quickly eliminate some of the answer choices? So I just combined friends and pulled to fooled. Two friends pooled their money to buy 5 CDs. Someone's still buying CDs in this world somewhere. One friend took 2 CDs to listen to. What fraction shows how many CDs the other friend took? So 2 friends bought 5 CDs. So you got 1, 2, 3, 4, 5. One friend took 2 of them. So friend A grabbed these 2, which means B grabbed these 3. What fraction shows how many CDs the other friend took? So A took 2 of them out of the 5 total, so that would have been 2/5. That means B takes the rest of them, 1, 2, 3, out of the remaining 5. So 3/5. B is the answer. What are these choices here? They don't go with those fractions at all. I'm extremely confused. I mean, B's the answer. I don't know what that's about. I think that there's supposed to be a choice up here, and then they ask you something down here about, well, what's the total? How did you know? And it's the 5 CDs aspect, the other one having 2. That blows my mind. That question is messed up.
It is actually not messed up. I left that in intentionally. I wanted to see if maybe anyone said anything in the chat, if they would catch me not paying attention. Like I said, I always like to leave stuff like this. I like to have my times when I try and catch y'all, and then I have times where I don't pay attention or I miss something like a detail, like you saw earlier with the tens versus the whole number for an answer. And when I was recording this, I didn't even read the top line because I was multitasking. And when we multitask, that definitely lends to making mistakes. So what I didn't read is what words in the following problem give you clues that help you quickly eliminate some of the answer choices. So that was the actual question. They did not want us to answer the question here. It's just what clue helps you eliminate some choices. So they say two friends pooled their money to buy 5 CDs. So you got two friends. One of the friends took 2 CDs to listen to, which fraction shows how many CDs the other friend took. So again, what words give you clues that help you quickly eliminate some of the answer choices? So answer A here is 3/4. Answer B here is 3/6. Those can both be quickly eliminated because the total number of CDs purchased is 5, which means the denominator would have to be, you guessed it, 5. So that's why the answer is 5 CDs. Again, the sentence saying there were 5 CDs total is the clue that A and C cannot be the answer at all because the denominators are 4 and 6, whereas B has a denominator of 5. Now, is that a 100% effective thing? Not entirely, because sometimes fractions get reduced. Like maybe they said there were maybe they said there were 10 CDs available, and 6 is how many one friend bought. So 6/10 would be an actual answer to the implicit question, but that would also reduce to 3/5. So that's what I mean by in that element, you have to be careful. But there's no way that having a total of 5 as a denominator can reduce to a 4, or a total of 5 in a denominator can reduce to a 6. Those are impossible reductions, and still that is valid. So again, I left that in intentionally. Sorry, just getting back to where we need to be.
What is the drawback to testing each answer choice in the original problem? It takes time, you might get the answer wrong, or it is hard to do. You might get the answer wrong, I mean, that's a possibility. It's hard to do, that's going to be dependent on your skill level, but it definitely takes time to test individual answers. That's why just getting a question and trying to, what's the phrase, spitball answers, it's a good idea sometimes, but it can be very time consuming. So just be careful with that. That's why I don't really like giving a lot of multiple choice questions on the test. I don't want people just testing out possibilities. I want them to derive a solution for logical quantitative reasons. The denominator of a fraction tells you, oh, you better know this. The value of the fraction, how many parts are in the whole, how many parts of a whole you have. Now, this is going to relate to how we were describing percent problems, part to whole ratios, part over whole. So the top is the part, the bottom is the whole. So how many parts are in the whole? Well, that would be the top. How many parts of a whole you have? Hold on, I read that backwards. How many parts of a whole you have? That would actually be the number of parts. How many parts are in the whole? That's poorly phrased, but it is the whole. The value of the fraction is the top and the bottom combined. The numerator of a fraction tells you how many parts are in the whole. Well, we just said the bottom was that, so it can't be it. The value of the fraction we just said is the top and the bottom combined. How many parts of the whole you have? C. Which is the best diagram to represent 3/6? Now, 3/6 does not have to be divided up into 6 segments. You could actually have it 1, 2, 3, 4, 5. All right. Ignore the size difference in these, but I can draw up a fraction, an image that would represent 3/6 by just shading a certain number of these, and I'll give that away at the end. So we take the shaded amount in relation to the whole, the shaded to the whole. So this would be 1, 2, 3 out of 1, 2, 3, 4, 5, 6, 7, 8. So that would be 3/8. This, there's 6 shaded out of 6 combined, so that's 6 over 6, which would reduce to 1. Whereas this, we've got 3 shaded, that's the part, out of the whole 1, 2, 3, 4, 5, 6. Now, yes, as a reduced fraction, that would be a half, but they just want to know how to represent 3/6. So another way is you could shade 1, 2, 3, 4, 5, 6, if there were 12 of them. 1, 2, 3, 4, 5, 6, that would be 6 out of 12, which you could also reduce to 3 over 6. Now this is not the best way because it doesn't clearly label them as 6 wholes and 3 parts, but it does work. So we're going with B. B is the only possible answer. My answer was not D. Fractions and decimals are used to show what is left when you take part of a whole away, what is left when you take away more than the number you started with, what is left when all of a number is taken away. If you take away more than the number you started with, that can't be just a part, that's more than the whole, so B's out. What is left when all of a number is taken away, or what is left when you take part of a number away? Well, if you take all of it away, if you take a whole away from a whole, you're left with nothing. So that's not really that great. So it's what is left when you take part of a whole away. Jana is going to install ceramic tile in her kitchen. Boy, if this doesn't hit home right now. Swap out kitchen for bathroom. It measures 11 foot 3 inches by 12 foot 6 inches. How many square feet of tile does Jana need? Now, calculators are not really capable of converting, of putting feet and inches in them. So we're going to have to do a couple of things here. We're going to have to convert your inches to feet and then just add them to the feet. So let's go back to this. Go. So we need to convert the inches to feet, then add to the initial feet. So for the first one, 11 foot 3, we're focusing on the 3 inches. How many inches to how many feet? While I don't make you memorize it, you should know it's 12 inches to a foot. I'm going to do the dimensional analysis way. You can do a proportion way if you prefer. So out with the old, so we know inches go on the top. In with the new, we know feet go on the bottom. And it's 12 inches to 1 foot. 3 and 12 we're going to reduce to a fourth. If you do the division, 3 divided by 12 is 0.25. Either way, you get 0.25 feet. So 11 foot 3 inches is really 11 feet plus 0.25 feet, and that is the symbol for feet. If you prefer to write the actual FT, go with it. So that would be 11.25 feet. So the 11 foot 3 inches is 11.25 foot. Now let's work on the 12 foot 6. So we got 6 inches. We need to know how much of a foot is that. Clearly we're multiplying inches in the bottom, feet in the top, and it's still 1 to 12. 6 and 12 will reduce to a half, so you get 0.5 feet. So the 12 foot 6 inches is really 12, I'll do it with the units written in words this time, 12 feet plus 0.5 feet, which is 12.5 feet. So these are our dimensions purely in feet. Our answer needs to be in square feet. If you have a length and a width, how do you find an area? You multiply. So that's all we got to do. So the area would be 11.25 feet times 12.5 feet. No matter what, our units are going to be feet squared. Feet times feet is feet squared. And then we just got to do 11.25. There is a decimal in there, even though it's kind of hidden. There we go. So 11.25 times 12.5. We get 140.625. The fact that I see that as an answer is a good sign. Square feet. Guess what? Literally just did this a few weeks ago. This is applicable math. This is stuff that could come up in your life a couple of times. Maybe you like remodeling homes. You're going to be doing this a lot. Another thing you might do is measure it in inches, but I can tell you when you go to the store to buy a tile, everything is pretty much measured in square feet. So if you make your measurements in inches, this is a more complicated problem because you'll have to convert from square inches to square feet, and that's where you have to multiply that by that 1/12 twice to get your inches to cancel twice and your feet to stack up twice. Jerome has to get to class, which is 4.7 miles from his dorm, in 30 minutes, aka a half an hour. If he's late, the professor will lock him out of class. Man, I don't want to say I wanted to be one of those teachers. A part of me wanted to, but I never was. I never locked the door. Anybody can come in, late or not. If he bikes 9 miles per hour, will he make it? So he can bike at 9 miles per hour. And we need to just do some math with this 4.7, this 30, this 9, some of these numbers and figure out how far will he actually go. So that's the first question we got to ask us. Whatever. Doesn't matter. How far will Jerome go? Half an hour. 30 minutes, half an hour. But because his speed is 9 miles per hour, that's why I'm talking about converting this thing to hours. So the 30 minutes, we know that there's 60 minutes to an hour, out with the old, so minutes in the bottom, in with the new, hours in the top, 1 hour to 60 minutes. 30 over 60 is a half, the minutes cancel, and it leaves you with hours. That's where the half an hour came from. And again, I wanted that because his speed is in miles per hour. So he's got half an hour worth of time. And he's got a speed that is 9 miles per hour. Remember, per means it goes in the bottom. So we've talked about how if you have just no absolute clue what to do and there's no formulas involved with things, if you got a bunch of things with units, just multiply and divide them in different orders, pay attention to how the units cancel, and then if the answer is the units you're looking for, it's probably the right answer. Now, there's a couple different ways you could try and do this. If you try and divide them, it's going to be wacky no matter which way you do this. So I'm going to skip the ones that don't work. The one that works, again, is not doing time divided by speed or speed divided by time. It's if I multiply these two things. So if you take your 0.5 hours and you multiply it by your 9 miles per hour, your hours units cancel. You're only left with miles, which is a distance, and that's what we're trying to compare it to. So this is a good sign. 0.5 times 9 is 4.5. So in that half an hour, he can go 4.5 miles. Jerome can go 4.5 miles in 30 minutes. Fortunately, he needs to go 4.7 miles. So no, he's not going to make it on time. So yes, he will make it on time is not the answer. They say no or no. Well, uh-oh. I don't see either of these answers in here anywhere. So what that means is we got to do some different math. So we know he can do 9 miles an hour, but it wasn't fast enough. Now we got to go this 4.7 miles, which is going to take more time. So now let's just try doing math with the 9 miles per hour and the 4.7 miles and see what we get. So they're looking for an answer in minutes. So if we get an answer in hours, that would also be acceptable. We just have to convert it after the fact. Okay. So now let's see how long for the 4.7 miles. So again, now we're specifically trying to hit the 4.7 miles. So the 30 minutes is out. We're not using that. We're just using the 9 and the 4.7. So if we do this, I'll do this wrong one way. let's say you wanted to do 9.7 miles per hour, and you said to multiply it by the 4.7 miles. These miles will not cancel, and your units end up being miles squared per hour. Huh? That doesn't make sense. So you can't just multiply them. What if you instead chose to divide them? Did 9.7 miles per hour divided by the... Hold on. I'm combining some numbers, aren't I? It's not 9.7 miles per hour. It was 9 miles per hour. Luckily, that didn't matter. So 9 miles per hour. Now let's try dividing them, because all I was focusing on was the units. Divided by the 4.7 miles. Well, dividing, that's 9 miles over hours. That means times, and then all this is in the top, so you put it in the bottom. And then you have a 1 in the top since there was nothing there originally. So your miles do cancel this time, and what you end up with is 9 divided by 4.7 turns out to be 9 divided by 4.7. It's 2 something, 1.9 something, about 1.9. But the units of hours are in the bottom, so it's 1.9 over hours, or 1.9 per hour. 1.9 what? How could that be the answer? First of all, this is about 2 hours. It's neither of these answers, so it's very obvious that's wrong. But it shouldn't take him almost 2 hours if in 30 minutes he went 4.5 miles. It's only going to take him an extra minute or two to go that extra 0.2 miles. So this definitely doesn't make sense based on the number. It doesn't make sense. And based on the units, that doesn't make sense. So again, this was wrong. But the thing about division is the order you divide matters. So let's try it the other way. So let's try doing the 4.7 miles divided by the 9 miles per hour, which is 4.7 miles times, and now just flip everything there so the hours go in the top and the 9 miles go in the bottom. See, your miles will still cancel each other out, but now your hour is in the top, exactly what makes sense to be a unit of time. And then 4.7 divided by 9 is about a half, 0.522222222, and that's hours. That makes sense. If he went 4.5 miles in a half an hour, it's not going to take him very much more time to go 4.7 miles. But the question is, they wanted this in minutes. So now we got to convert to minutes. So we take this, and I'm leaving all of those up there in my calculator. 0.52 bar, that was hours, times, converting hours to minutes, out with the old, so hours in the bottom, minutes in the top. 1 hour to 60 minutes. The hours will cancel. So we're just multiplying that 0.522222 times 60. And we get 31.33333333. So it's going to take him 31 1/3 minutes. We got it right. That question is a decent amount of things to process. The first thing I did was just to get a yes or no. Admittedly, I didn't have to do that. Admittedly, I did not have to do this. I could have just done the last bit, because when I got the answer of 31.33 minutes, that would have also told me, no, he won't make it. So this was technically the only thing you had to do for this problem. However, I know a lot of students would have tried to figure out whether he makes it or not first and then do the actual calculation. Again, all I did was just take two numbers with their units in appropriate places. I multiplied them, I divided them in a different way, just trying to get the units that the answer would make sense in, and then hopefully the number makes sense. Sometimes you can't make sense of the number though. In the word percent, per means 100, and cent means 100, so it means 100, 100? No. Does per mean times, so times 100? No. Means for every 100. All right, last one, and we'll call it a day. Which equation correctly shows the statement that 63% of the prairie dogs in a colony of 300 prairie dogs are light brown? So we know the percentage of them, we know the total of the colony, but we don't know the part that are actually brown. We don't know something, so it can't be A. It's got to be B or C. Now, the 63% is the thing that's supposed to go with the 100. So 63 over 100, which makes B the obvious choice. But I also want to talk about why the X goes on top and the 300 at the bottom. The colony is 300, that's the whole, and it's always part over whole. So that 300 has to go in the bottom, and there we go. All right.
All right, so like I said, that's where we're going to call it for the day. As always, if you have any questions, you can shoot me an email. I'm hoping that this recording is going to go up fine because Zoom was saying my live mic was being weird. I don't know. Something's going on with the technology today. Not just technology, me. My computer's sick, I'm sick, everything's sick. Okay. All right. So besides that, have a good day. When we come back on Wednesday, I think what I'm going to do is a midterm review. I'm going to do some questions from the midterm review so y'all have a little more experience with it. And yeah, so we'll see that next time. Take care, everybody.